So the affirmative claims the hazardous impacts of my site and compares it to 3 Mile Island, brings up tube thinning, talks about the reactor and pressurized water, talks about earthquakes, and makes a statement that California can run without San Onofre. So, going back to seismic safety, the NRC is the Nuclear Regulatory Commission. It requires nuclear power plants to withstand the maximum credible scenario for the plant's locations. So it has been San Onofre has been certified for its most credible potential earthquake. The U.S. NRC requires every nuclear power plant to be designed to withstand an earthquake at a design level that is based on the maximum credible scenario for the plant's location without any release of radioactive materials. Furthermore, U.S. reactors must be designed to safely shut down during any such earthquake, so that in the event that there was an earthquake, the power plants are supposed to shut down immediately. However, peak ground acceleration is a more meaningful way to measure an earthquake's potential impact. While the Richter scale is one common way to measure the magnitude of earthquakes at its epicenter, when assessing the seismic safety at nuclear facilities, peak ground acceleration at the facility's location is a more meaningful way to measure an earthquake's potential impact. To meet the U.S. NRC standards, San Onofre was built to withstand a peak ground acceleration of 0.67 G, which refers to force of gravity, resulting from the maximum credible earthquake. By comparison to the initial estimates using information from the United States Geological Survey of the peak ground acceleration, my opponent did mention that some of our information was outdated. However, Southern California Edison was recently reevaluated for seismic hazard analysis. And Southern California Edison periodically updates the plant's seismic hazard analysis using the recent information from the scientific community. The most recent reevaluation was completed between 2009 and 2011. The evaluation continues to demonstrate that SONGS, or San Onofre, has appropriate engineering features, processes, and procedures to protect the public in the event of a maximum credible earthquake or tsunami. Last month, they provided the most recent evaluation of seismic and tsunami impacts, and this was addressed. And going back to my opponent when she talked about 3 Mile Island, she wants to compare a 1980s power plant to a 2010 facility. The reason why the meltdown happened at 3 Mile Island was because of tube plugging. As of January 11, 1999, 3 Mile Island is operating with thousands of damaged steam tubes. It has the first operating generator has 1,300 tubes, while another has 1,600 tubes. Together, it has about 15,000 tubes plugged. What happens is when the tubes are plugged, it causes backup. What my opponent, however, did mention was that the problem with the meltdown was because of the operator to machine problem. And we're talking about outdated information, computers from the 1980s. We have facilities now that pretty much detect everything on a better level. And going back to that, tube thinning, the NRC has a limit to the amount of tube thinning. Tube thinning happens because of pressure, of the pressurized vapors inside those tubes. The credible amount that a tube can be thinned out to is 40%. And that's being conservative. My opponent mentioned that some of the tubes didn't go over 35%, and keep in mind that NRC did say 40% was the maximum credible thinning for a tubing. In addition, our opponent stated that we're overdue for a big quake. However, most of these big earthquakes are being attributed to the San Andreas Fault. However, San Onofre is not located on San Andreas Fault. It is actually located on the Newport Inglewood Rose Canyon, and so it's not even comparing to the information that our opponents gave. Furthermore, our opponents wanted to compare Fukushima Daiichi to San Onofre. However, these two are completely two different plants. They sit on two completely different fault lines, and they operate on two completely different operating systems. For instance, Fukushima Daiichi uses a boiling water design, while Songs has pressurized water reactors. And one of the key advantages of pressurized water reactor is that it has two cooling loops of primary and secondary separated by steam generators. The significance of the steam generator is that the water steam from the secondary system can be vented into the atmosphere to remove heat from the nuclear fuel without releasing radioactive steam gases, because the water being vented has not been in contact with the nuclear rod. And the fault types are completely different too. The earthquake fault system that produced the devastating earthquake near Honshu, Japan, originated in the subduction zone, which means subduction is basically one plate goes over the other. And San Onofre is located on a strike slip, so the plates actually slip right next to each other. Tsunamis can be produced by an earthquake in a subduction zone, are projected to be larger than resulting from earthquakes in a strike slip fault, such as the Newport Inglewood Rose Canyon faults near San Onofre. And furthermore, my opponents say that San Onofre can run that California can run without San Onofre. But why is it that last year we had flex alerts? If we are over the amount of energy being produced, why is it that the California Energy Commission is telling us flex alert, you need to reduce the amount of energy you're using? That makes no sense. And again, that is going to be another common thing that's going to be seen this summer if San Onofre does not come back up. My question to my opponents is, why are you comparing an old reactor from the 1970s to our present-day reactor? And furthermore, why are you comparing Songs to Daiichi when they are two completely different generating plants and two complete faults? Thank you.